again grateful and final presentation to this meeting from our group. As I told you that we are working for comorbidity and slight variation in behavior on the neurochemistry or neurophysiology and neuropathology. Therefore, for us, it is very important the combination of simple mild factors like mild hypertension, mild increase in ambient temperature, and a combination of them could be different than the normal individuals. We still give them in a category comorbidity factors, and it not necessarily should be a disease, it should be certain stressful situations, certain increase in temperature working the same way. I think it could be different, and we are very grateful for cooperation because, as I told you, we're into EU cooperation gives us some money that we can do it, and so we are trying different ways of things, and this is silica, very well known, is quite common in desert areas. Not nowadays when many countries have their soldiers in Middle East, but still this is a problem that normal human populations are exposed to silica dust, and it could have different devastating effects or at least modulating effects on their brain function. They are not same. The again situation is the stress, and the military or soldiers should not be lying in all these positions for a long time, but it could be immobilization when any soldier from any country is just attentive for several hours looking for possible enemy or gunfire. This is also a stress, and this is also immobilization. It should not be like that. So these are very important events in the battlefield, and it will affect a variety of physiological parameters leading to pathology. In that circumstances, even small effects could be dangerous. I'm not talking here about neural trauma, but these things must be considered. So we try to study comorbidity factors in different areas, like what is the effect of hypertension, subthreshold hypertension, diabetes, and other factors. We have shown some of the results from our group. And these comorbidity factors are gaining ground. And I had a question that some drugs failed. I think the comorbidity factor is very important, and I'm very happy to tell you that our comorbidity factor influencing therapy has been again selected as a policy paper from Society for Neuroscience in New Orleans. So it means that the expert committee consider that these are the new fields and we should consider as a policy matter in future neuroscience. And also, Dr. Moresanu, who is not here, is also dealing with different kinds of comorbidity factors influencing neuroscience functions. So I guess this is a new area of science that we are doing, and we did this volume compiled, just published, telling some of the aspects that even we have studied certain forms of Alzheimer's disease in knockout mice. If they are put to different conditions, their pathology is different, but these are other stories. We also try to aware by scientific literature. This book is old, 2009, where we have given emphasis that neuropharmacology or nanoneuropharmacology could be different depending on different kinds of disease and conditions. So coming to the point, exposure to silica, we have studied in this model that I am presenting. It should be the combination of mild immobilization stress and mild hyperthermia, or a combination of both. So I will be very brief. So our model is, we created hypertensive model, and this is very old model of 2 kidney, 1 clip. Both kidneys are intact, one renal artery is clipped, and animals are allowed for 4 to 6 weeks. The other situation is that experiments were done at 21 degrees Celsius or 33 degrees Celsius. In our hands, I show you some results of the disease of our 38 degrees Celsius. If rats was exposed for 4 hours, their barrier is open. At least 31, 33, nothing happens, at least up to 4 hours. Also, the immobilization we have published in 1996 or Very good. 6 to 8 hours of immobilization in different age size of the rats. Again, this is question of aging and this is quite common. Opens the barrier, but not 4 hours. So what we try to study, we have the half threshold of the stress and then combined with silica exposure. And let us see what we got. There are different models of immobilization, and we have used this model where the rat is placed in this tube, it is well ventilated, and there were many questions from psychiatric people that if you place 2 rats without this ventilated tube or isolated, then the rat will have excreta and urine, and some other rat would have a smell, and the brain function will change, because we should remember that the smell physiology got the Nobel Prize recently. So therefore, this is the equipment especially made that the rats will not feel any smell, and they were kept here, aerated, and it's not completely restrained. And this was the chamber for hyperthermia, where this humidity and airflow is well controlled. The experiments can be done 5 degrees to 50 degrees Celsius. So we measure blood glucose level, and we can see that tube kidney, 1 click, 1 week, there was slight increase, as I told you, from European standard. 6 and 6.5 is quite normal. So I believe that it's still under all various circumstances, immobilization at 33, immobilization at 21, and tube kidney 1 click means hypertensive, I will tell them, plus immobilization at 33 or 21. Not so significant difference in glucose level from clinical point of view. So the changes that we are seeing may not have any direct effect of hyperglycemia or hypoglycemia. But there are some changes in blood pressures that is quite obvious. This is mean arterial blood pressure. And you can see normal rats have 120 average. Tube kidney were 140 to 160. We deliberately don't use those rats in which the blood pressure increases beyond 180, because the work of Barbara Johansson from Sweden suggests that if blood pressure increases beyond 180, there is a spontaneous leakage of blood-brain barrier. So we excluded them, and so even 4 weeks after, the blood pressure was not above 180, it is below. When we have given immobilization and hyperthermia at 21, there is slight increase in blood pressure. And at 33, we thought that it will increase, but at this time there is slight less increase. Whereas this control immobilization at 21 and 33, they are not so much increase in blood pressure. Then we have used various standard methods of cognitive and sensory function. This is the manual rotor experiments, where we allow 16 RPM, and rats can stay for 1 second. Normal rats. And this is the inclined pain angle, 60-degree standard. The rat can stay here. Otherwise, if there are some problems, they can slide down, or you have to lower the angle. So the first thing, that this behavioral function, and as you can see here, that control could stay for a longer time. Hypertensive rat, 21 degrees centigrade, there is some less. 33 is even less. And the combination of stress and hypertension was almost similar. But when the hypertension and immobilization stress were given at high temperature, 33, you can see there is significant reduction, although the individual variations were large. When we have given silica, introduced silica there, and this is still high tension, 21 degree, you can see that they were not like as normal. At 33 degree, much more deterioration. When we have used immobilization, hypertension at 21, they are almost similar, but you should see here, immobilization, hypertension and 33, there is dramatic loss of these functions. And in some of the situations, there is quite common that people are having 33 degree ambient temperature, then they have also hypertension produced by simple stress. Either it could be combat stress or washing or whatsoever it is, and immobilization. So there is a lot of changes in cognitive and sensory function, their attentive function. I'm not going to comment that why in certain areas some soldiers do suicide or kill their colleagues. I mean, these are the questions that we can't comment, but these are the problems, these are psychiatric problems. So we believe here that silica neurotoxicity is higher at 33 degrees Celsius. Immobilization has greater effect at 33 degrees Celsius. And a combination of a stress with silica is much more harmful. Now I will show you some of the data, and again with radioiodine leakage. This is in different brain areas. Brain is a compact organ, and I don't need to describe here to you people, you are expert in that. But each area has different function. So maybe even in cortex we describe occipital cortex, temporal cortex, parietal cortex, but these changes are not similar or same. There is a lot of difference between frontal cortex and occipital cortex, although they are the part of same cortex. So these are real changes. These are not shared. These are not artifacts. So that this we must consider. So you can see here that this is cortex, hippocampus, striatum, thalamus, hypothalamus, brainstem, and spinal cord. The point you should look here at that we have maximum effect of hypertension, silica, stress at 33 degrees Celsius. And you can see that the leakage is very high in those groups. But there are significant difference among the regions. The water content. Water content also goes like this. Since the scale I should have done at this lower level, but we have to accommodate this. So you can see the differences are here, but in this situation again, hypertension, immobilization stress, and silica at 33 producing more adverse effects. This is damage or distorted neurons. Again, the situation is they are highest in this group where the combination of the stress, silica, and high ambient temperature was given. I'm showing you damage here. This is stress, hypertension, silica 21. The same situation at 33, and here is only hypertension 21 and 33. So the result are obvious. Highest damage is occurring with silica, hypertension 33. So the point is that when we add mild stress, those kind of stress by itself do not produce any damage. Whether it is emotional stress like immobilization, this is a model of depression as psychiatrists or neuropharmacologists say, and ambient temperature is 33 by itself do not have any devastating effects up to certain period. When they are combined, their effect is a synergistic effect. And then if we add nanoparticles, for example, silica is much more devastating. I will skip this and I will listen again to your expert comments so that we can go in right direction further or improve our methodology or protocol. Thank you very much. We can collaborate. Next time we do the experiment, we can send you the Intel state. You can analyze by yourself.
But the reason, I mean, in a similar, I think I answered your question about, you were talking about heat stroke.
Yeah.
And it's been shown in Singapore that heat stroke can be preceded by opening of the intestinal lumen. That will go ahead and cause this. And I was just wondering whether or not the higher temperature may be exacerbating that, and you're seeing the synergistic effect not just with the particle, but also with the infiltration of bacteria.
I believe that there is a blood-intestinal barrier too, and also blood-testis barrier. We believe that all these barriers, even the blood-body barrier, I am not an expert, but you are. It could also be possible that all kinds of physiological barriers are damaged under the same circumstances, but this is a matter of further investigation.
I think this kind of fits in with genomics work.
Yeah, you do not have resources to do that, but I mean, somebody should do it. I mean, they cost lots of money. Genomic or microarray experiments. I don't have that much money.
No, but I think it's the same notion of we used to take a laboratory animal and
Yeah, sure.
experiment, and yet there's something about the fact
Yeah,
that
sure.